marine minerals. That is a forum which was formed 2 years ago, 2019, and actually pretty big group now, a lot of companies. Some of these companies are actually new startups for specific deep sea mining purposes, and some of the old companies that you recognize, and some organizations, so on. The whole idea with this forum is to kind of get as much information as possible to understand the kind of significance, the opportunities, and the more problematic stuff with deep sea mining. So that is the objective. So let me just start very fast with where these minerals are located. So as you all know, 70% of the Earth's surface is covered by oceans, and the plates of the Earth's surface are split along these lines, as you can see. And along those fractures, you have these what we call hydrothermal vents. That means that you get kind of hot water coming up along the cracks, and they form actually deposits which are metal rich. So if you look at the countries around the world and who owns what, the darker sites outside the continents that are exclusive economic zones, and the small dots you see in the middle of the ocean, that are islands normally. If you look at the rest of the area, that is what is called the area. So the area is covering about 50% of the surface of the Earth, and it's administered by the United Nations under what we call the International Seabed Authority. So it belongs to all the world. And we are talking about minerals, metals that are covering, as I said, 70% of the Earth's surface. There's a lot of potentially rich deposits out there, and it has been difficult to understand who owns what. The area is owned by the world, and there's a lot of discussion. They have been discussing this at United Nations for 40 years. Who should benefit from this? So I come back to that a little bit later. Norway, we have had a big, how can I say, impact assessment over the last 3 years, and it's going to a conclusion now next year. The brown beige area is the area that the geologists think are most interesting in terms of metal and mineral-rich deposits. And it's along the mid-Atlantic ridge. As you see, the mid-Atlantic ridge is not as straight as the one I showed before. It's not just kind of lines, but it's a bit more complicated. You see, Iceland, for instance, is on this mid-Atlantic rift, and you have a fracture zone. Jan Mayen is there, and you have various areas. And we have had this brown beige area is about 590,000 square kilometers, which equates to about 1.5 times the surface of Norway. So that has been the kind of the impact assessment area that have been studied now in more detail over the last 3 years. Now you see the hydrothermal deposits and the hydrothermal active and inactive, and mangan crust. I will come back a little bit what these kind of areas are, but here you see kind of an outline of the area that has been under consideration. It turned out that last week, or maybe the week before that, then the pink area is the area that Norway will now consider as most profitable, most interesting in terms of these metal and mineral-rich deposits. So as you can see, the area has been reduced somewhat from 590 to about 320, 330,000 square kilometers, which is the same as Norway's land surface. But I will come back a little bit why it's like this. So let's just look into the deposits. You have polymetallic manganese nodules. This is super PMN. You have cobalt-rich manganese crust, CRS, and seafloor massive sulfides. Norway, we don't have any polymetallic manganese. That is the most rich deposit in the area. That is what is governed by the United Nations. We have cobalt-rich manganese crust and seafloor massive sulfides. Here you have an example of polymetallic manganese nodules, small potato-sized nodules, quite easy to recover, unless you think of the depths. These are not normally found about 4,500 meters sea depth. So it's a bit deep, but still it's kind of easy. I mean, it's just to pluck them up, and these are very rich nodules. They consist of manganese, copper, cobalt, nickel, very important stuff. So, but Norway, in this Norway exclusive zone, we don't have it. There was a big event happening a week ago, because there's a company called the Metals Company, TMC. They actually started a production test of this. And as you can see to the right, now you see all these nodules coming up from 4,500 riser. The picture to the left is the tractor or the excavator that actually collect these things. And you are in Stavanger now, and you all know that it's easy to collect stones from the fields in more or less the same matter. Beside the small problem that is 4,500 meters sea depth. So it happened, test production, just 1.5 weeks ago. So I'm happy to share that with you. So now it happens, it works. When it comes to the crust, it looks like this. And it's kind of covering kind of steep sea mountains in the deeper oceans, and maximum 25 centimeters thick. It's kind of a crust. I normally used to make a similarity to the plaque you get on the teeth. Even if you brush your teeth every day, you get some kind of ions sticking to your teeth, and it's there. And that material, which is a nuisance in the oil and gas industry, as you know, because it normally plugs the pipes. That is something happening about 1 centimeter per million year. That is about 1 to 2 atoms per day. So it's really a slow process. But if you look at all the sea mountains in the oceans, in Norwegian oceans, you see kind of a cover of these metal-rich crust. Why is it only on sea mountains? Because in the deeper ocean, the sediments will cover this up. So you need a little bit steep slopes in order to have manganese crust. Of course, you find also manganese crust all over the oceans in the world, but we have this in Norway. Here you see kind of a cartoonish sketch how this is worked. Ions are sticking to these kind of steeper slopes. So manganese, dysprosium, neodymium, scandium, rare elements, kind of elements you find in this deposit. It's not a cross section, but it's a kind of a thick, kind of a thin skin, if you like. So you can just imagine how to get this out. You have to scrape the bottom. Then you have seafloor massive sulfides, the so-called SMS. These are more common, and we have this in Norwegian waters. You are familiar with the black smoker. This is a sketchy cartoon as a black smoker. It means that you have the water enriched with ions of metallic water coming up. It creates a kind of a cloud, but it also deposits these metal-rich deposits outside the cloud. So these are actually the deposits that you find in the copper district in Norway, typically Røros, which is the kind of one of the foundation of Norwegian industrialization that is based on ancient black smokers that have now moved to above sea level, if you like, because of tectonic changes. But these two are actually the Norwegian kind of possibilities. And you know, zinc, copper, cobalt, iron, gold, typical stuff you find in these kind of settings. We have been working on this for quite a long time. University of Bergen have been studying these fields, if you like, since 1998, I think. And the Norwegian Petroleum Directorate have been working on a kind of a professional basis, if you like, since 2019, when the impact assessment started. And you can see some kind of, I mean, this is a big area. We are talking about the land size or the area of Norway, and a few samples have come, and that is what we based our studies on. You see the cores here. There is a few, maybe a few cores, 1 or 2 cores taken from samples, and that is what we based our information on. Here's some very nice bathymetric map of the whole area, taken from Norway to the right and Greenland to the left, or the shelf at least. And you see in the middle there, that is the Mid-Atlantic Rift, where we have these deposits. The lines there, they are magnetic lines. As you know, every now and then, the north and south pole, magnetic north and south pole, switch direction. So you can see how it develops over time. So that is the numbers 5, 5, 6, 6, 7, 7, and so on. It's magnetic lines. It just change direction when the Curie temperature solidifies the magnesium, the magnetic material in the lava. So for those of you who like geology, here's an example of an ROV doing some sampling in the in Norwegian waters. So why do we talk about this? Well, there's an energy transition right now, and we need to kind of change focus from oil and gas, which accounts, or coal, oil and gas, so-called fossil fuels, accounts to about 83% of the energy used today. Of course, it causes also CO2 emissions, and there is a great demand for a green shift. And these minerals that I'm talking about now, they're important for the energy shift. You see also that geopolitical challenges can change matters. We see that not for minerals as such. Well, there are also minerals, but you know what happens in with the gas pipelines to Europe from Russia, which are not existing anymore, of the northern routes. So it's kind of same thing with the raw materials. And we never know what will happen with the raw materials. They can be cut off of various reasons. And very important is a possibility for a profitable industry. And the first slide I showed you with my forum, if you like, 3 of the companies are startups and coming mostly from the oil industry. And because the guys who have been investing money in the oil industry knows that this could be a profitable industry. And of course, industry will also lead to jobs, which is also important for us all. Now, IEA, the International Energy Association, they say that by 2030, 7 years from now, we should have 60% full electric vehicles. So I'm in Brazil now. I haven't seen one single electric vehicle. I guess if you look out of the window, you will see Teslas and Leafs and BMWs and I don't know what. So in Norway, it's the kind of outlier here. But according to the net zero by 2050, we should have 60% global electric vehicles. And that, if we kind of comply to the IEA's prediction, I mean, in 2040, we should be, I can't remember, it's 80% or 90%. And 2050, it should be almost 100% electrical vehicles. It creates, sorry about the Norwegian spelling here now, but it means 7 times more critical minerals. If we are going just for the period until 2030, how should you do that? There's a lot of mines around the world. We need 7 times more critical minerals to achieve the goal that IEA has set for 1.5 degrees increase in temperature from industrial level. That is the report saying. So it's a lot of demand. Here you see the critical minerals. Those of you who are chemists, you know that the periodic system has, I don't know, 92 natural elements. And, you know, there are a few of them here. They are quite critical. This is the EU's list. EU consume 25% of all the minerals in the world, and they produce 3% of the minerals in the world. Just imagine, if you have some geopolitical problems, as we have seen for the oil and gas, then you are in deep trouble. So there is a big demand for EU, but of course for the whole world, but for EU, it's kind of critical, because there's something called not in my backyard, and that is going on in Europe. Nobody likes a mine next to you, next to your town, city, village, whatever. So yeah, And of course, things happen. Bad things happen. This was the shipping container ship in this Gulf of Suez, the Suez Gulf, a year ago, and big disruptions happen. A lot of congestions of the, and all these things that we see now. I mean, you can just look out of the window. I don't know in Stavanger if you can see that, but in, let's say, in China, a lot of container ships or ships in general are waiting for access to get here to there, because these very unlikely events that we call black swan events, they are happening quite, I mean, it's not really black swan. The COVID stuff, the COVID epidemic is also a black swan event. And then you have the war in Ukraine and so on. So there's a lot of unexpected events that could really change things. Look at what happened in 2010. Then China had a problem with Japan, some, quarrel about islands and fishing ships and whatever. And China just cut the supply of rare earth elements. And the price just jumped up 10 times. Factor of 10. Now, China also joined the World Trade Organization in 2001. So they were convinced of reducing this kind of sanction towards Japan. So the price went down, not to the level it used to be, but still not the times 10. So it means that we never know, in a way, when one material, one element is going up and creating havoc. For those of you who are not familiar with the raw materials these days, you may have a check on coal. Coal is now 10 times the price it was before 1 year ago. So now it's about $500 per ton. It used to be 50. So it's like all materials kind of react towards kind of crisis around the world. Now, minerals are used for solar, wind, batteries, electric infrastructure, and and how can you get this? Then, of course, all the materials today come from production from mines on shore. Well, not all. You also have recycling. We all know that the Coke boxes are recycled to a certain degree. But then we have the third element here, that is, we can actually also get metals and minerals from the marine minerals. So, sorry about this. I just got a message that my computer almost like to restart itself. I hope it does not do that within 3 hours. So that's okay. Now, let's check up what is this about. Recycling, it's kind of, you produce something and you put it into the correct box, if you like, and out it comes again. So if you have aluminium, you collect it, you process it, and you use it, and then you use it again. Around 25% of copper is recycled, and rare earth elements, as I just mentioned, that is virtually not recycled. I mean, it's not recycled. In your mobile phone, in your PC, the one you use today, there are a lot of elements there. And I would say 99% of those will never be recycled. Why is that? Because there are a few of them, of course. I mean, you don't need too much indium. I mean, I have a screen here in front of me here now. It's a touch screen. And indium is one of those kind of rare stuff. You don't need much of it. But if I don't have indium, I cannot touch my screen. It won't work. So if you like to not use these materials, your smartphones, your PCs, and all your nice gadgets will not work anymore. So that is kind of the importance of that. So, but it will not cover the 7 times increase in the metals and minerals needed. Of course, I mean, you can recycle what is there, but you cannot recycle a factor 7. So that's quite natural. So onshore mining, that is where we get the metals from now. Everything you have around you, look around, just take a glance 1 meter beside yourself, and you find metals all over the place, right? And all the metals are found from onshore mining. It comes from a mine somewhere. And these mines some of them have been existing for hundreds of years. I mean, I'm in South America now. I'm in Brazil now. It's a huge country for metals. I mean, when the Europeans started to with the Spaniards and the Portuguese people, in a way, found in inverted brackets South America, they started to export silver from typically Peru and from Bolivia and so on. These mines are still existing, and that's where we find most of the metals now. And there are, of course, other places on the earth. This, I guess, is from Congo in Africa. Now, if you look at it, it's depleted. It means that the grade goes down because we have used it for so many years. I mean, Christopher Columbus, he came here in 1492. So I'm a little bit late to come to South America. He came in 1492, and we have had mines in South America since then. So they're depleted. It means it's get more of the not valuable stuff compared to the valuable stuff over time. Geopolitical risk. When the war in Ukraine started, for instance, nickel production from Russia started to become, Russia is not the only one to produce nickel, but some of the countries have really big production of certain minerals and metals. And if you get into, problems, China is a problem with US, as we know, and US is a friend of Europe and so on. So you never know when things that we think we take for granted are not there. So it's kind of difficult. Environmental stress, that means it's tough to make this hold in the ground for the environment, for biodiversity and other things. And poor working conditions, some places it's really bad. Africa is a good example of that, where you see really poor working conditions for the cobalt, which is also part of the battery that you have in your iPhones or the Samsung or whatever, your telephones. So all of you sitting around the table here now, all of you following this discussion will probably have really poor working condition metals in your hand right now. Sorry to say, but this is how it works. So deep sea mining is an alternative. It's not the solution that will take everything, but it can be a supplement, because since we have so enormous areas in the seas, I mean, the area, as I call it, the United Nations administered area, that covers 50% of the globe's, the Earth's surface, 50%. So there's a lot of metals out there. And of course, that is, so it's rich. And these deposits are also rich. Now, you may wonder, why should we go down to the deep water to find these things? But they are there. We know they have been there for, Darwin was the first to discover these nodules back in the mid 1800s, 1850 or 1860. They discovered that we had these nodules there. And the sulfides, they were discovered later, but still we know there's a lot of materials out there. It's kind of it's a competition to the land mining, but it's there to help us do this 2050 net zero goal. It should be technologically and environmentally feasible. Some people will not agree with me when I say environmentally feasible, because some people think that the microbes and the small animal does not much in around 2, 3, 4, 5,000 meters depth, but there are small organisms living there. And some groups think it would not be good to destroy that. And therefore, they would like to stop this kind of industry. And when it comes to technology, I'm an oil and gas man myself, working for 40 years with the oil and gas industry, if you like. And I think working on deep water is something that will be able to fix by the technology, either from the oil and gas or from other technologies. But I know it's possible. But I think if you look at that sentence, technological and environmentally feasible, that is the key question if we are going to kind of start this industry. I think it's technological, possibly. Environment is one of the challenges. We have to do it in a very careful way, not to disturb kind of the biodiversity we have in deep oceans. And it's spread all over the world. So the International Seabed Authority, based in Kingston, Jamaica, that means that if we start production, then it will be spread also to the poor countries. That is one important factor, and also the landlocked countries. They will take benefit of this. So if you, let's say, just take an example, if you start to produce from these international waters, then a certain percentage should go to poor countries and landlocked countries. So that's one of the good thing about this. Now we can look into the interior of the Earth. This is from a colleague of mine. This is Ståle Johansen, who did a survey with electromagnetic waves. It's EMGS, this oil and gas exploration tool. And you can now, this figure shows you actually a picture down to 120 kilometers depth. And I guess you have never seen a picture that is real into the Earth. I mean, normally you see cartoons from the glossy textbooks from geology or whatever. But this is actually, the warm colors indicate a conductive materials. The cold colors are non-conductive materials. So conductive means that you have metallic rich deposits. So if you look a little bit up to the upper surface, you can actually start to see where should you go to find the conductive materials, meaning where should you go to find the metal rich areas. So we have tools. I'm a geophysicist myself, and you can use seismic to see kind of the details of the upper surface. You can use electromagnetic sources. The sun is one of them. And also you can use a control source in this case, and you can combine them and you can see into the Earth's interior. You don't need to go to 120 kilometers because mining of deep sea mining will probably be only on the first max 50 meters or something like that. So it's kind of shallow, but still it's important to know the source of where things are coming from. Yeah, here's another nice picture of the ROVs coming down here. Oh, sorry, I'm doing it wrong. Sorry about that. So it can use oil and gas industry materials, EM. Yeah, and here's a report that came out 2 weeks ago from the Ministry of Petroleum and Energy, and that is interesting. Here you see some examples of ways to do exploration. You can have, grabs, you can do sampling, you can do echo sounding. Sorry about this in Norwegian, but you can use sonar, seismic, and so on. What we need to do is to get the materials from the sea bottom when we have found it, doing exploration as on land. You do exploration and then you go for the production, and then you have a certain way to get it from the sea bottom up to production vessel to get lead to the market. And then oil and gas technology is there. I mean, it would be some kind of riser technology. And you need to lift it, you need power to get this up, and you need to crush it. This is really far out in the sea, so it's kind of challenging for power. You need control systems, you need vessels for storage. And here you see some ideas about production. You see kind of bulldozers scraping the surface, getting it into the risers and up. A lot of ideas. You can have trench diggers to the left. It's like a trench digger. You can go down, take out materials, and lift it up, and so on. Some ideas of how to do it. And a lot of companies are really looking into this. It's brand new. It's more or less based on the land surface equipment for mining, but marinized it to withstand deep waters. The upper left is this trench digger, which actually cut down trenches and can lift up the material afterwards. You can use a lot of ideas from the oil and gas. Riser heave compensation systems is one. You can use pipe and pipe with a slurry of material going up and water down, and you can use wind power to get electricity to avoid using carbon waste to produce things like gas powered systems. You can use dynamic positioning to position the boats, and you can use all kind of AUVs, ROVs, and so on to maneuver yourself down there. Here are some examples of these ways to work underwater. Remember, these are pretty deep water. Some of them are for the manganese crust. The one to the left is typically a scraping. It looks like a lawnmower, klipper in Norwegian, that you just scrape off this, as I said, 25 centimeters of layer, very metal-rich layer. The one to the right is more for the sulfides, where you can kind of dig down, drill pipes and get up materials. And then you have some on the lower left, we have all kind of machines that are more familiar to the land mining, that are kind of marinized to deep water. Rystad, the Norwegian company, has done a study of what would be the consequences of starting up a deep sea mining industry in Norway. And they have kind of these ideas. If you have 10 projects, 50, 10, 25, 50, 75, then you actually could get a lot of jobs. They estimate in the lowest case about 4,000 new jobs, 21,000 in the 75 or 100 type of projects. So it means that for Norway, it is not just an industry to get these very important minerals and metals, but it's also an industry that can be provide us with money and jobs. And you can also see that this industry can also be exported to other countries. So as we have seen in the oil and gas industry, Norway started producing oil and gas, but they also started an industry on supply of equipment, ships and so on. And I think just 5-6 years ago, it was the second biggest industry in Norway, the supply base. And this can also be one of the industrial vehicles for Norway to have a new kind of industrial development for that. Now, there is a very important process going on. I didn't say this, but in 2019, when we've started our forum for marine minerals, we got a law on the seabed in order. And 1st of July 2019, we got a law on the seabed minerals. So we have a system of law regulating such a process, such an industry. It's based mostly on the oil and gas law when it comes to licensing, and it comes to all kind of regulatory methods. And in 2020, we started the impact assessment on konsekvensutredning in Norwegian. It means that the Norwegian government started to ask every participant, if you like, in Norway over a period of 3 years, what would be the consequence of starting such an industry. So it started with the ideas of what should be considered. There was a hearing in 2021. Now we are into the last phase. And I can just jump to the right picture. In June, second quarter of 2023, meaning just a half year from now, the Norwegian Parliament will decide if we are going to open up for licensing, exploration licensing of deep sea minerals. We have been working for 3 years. Some of the figures I showed you in this presentation come from a report that came from the Norwegian government just 2 weeks ago. So this is kind of the information gathered by the Norwegian Petroleum Directorate on behalf of the Ministry of Petroleum and Energy, considering kind of environmental factors, business factors, technological factors, and so on. And there will be a hearing until mid-January 2023. And you can all, those of you who follow this webinar, you can get your ideas out there, and it will be considered if it should be included or not. And then there will be a report coming out with the politicians, our elected politicians will make an assessment of this, and they will decide, yes, shall we start exploration for deep sea minerals in 2023, 2024, that is now very soon up for discussion. When it comes to the international waters, the United Nations, it happens at the same time that in 2023, there will be a decision, I hope, from United Nations if we should start producing the minerals from the area. That means the big area administered by the United Nations, excluding the economic zones around countries. That happens at the same time. So we are in an extreme crossroads now. So next year, 1 year from now, possibly we could have exploration, big business happening in Norway. At the same time, we could have big time production worldwide. It's just a few months from the decision. If it will happen, I don't know. But of course, we will have to take into consideration all effects here. And the job I run for the Norwegian Forum for Minerals is to inform as good as we can all stakeholders, including the politicians, to get to just do the right decision. I don't know what the right decision is, but the politician will have to make a decision. So, yeah, here you see the face. So I will just go for the conclusions. We have a very big area in Norway for deep sea mining. It's the same size, even after reducing it from 570,000 square kilometers to 320 or something. It's still the size of Norway. So it's a very big area. And as you saw, only a few samples taken. So we don't really know the potential. We don't know how big the resource potential is because there are so few wells. It's like when we started oil and gas exploration in the 70s in the North Sea. I mean, there were a few wells. We had no idea. We didn't know that Barents Sea would be less profitable than the southern North Sea. Now we know. It's the same here. We have to do exploration in order to understand more. We have this law on seabed minerals. That is really important. If we have a law, that means that companies can risk capital on this. If we don't have a law, you know, who would dare to go out and risk money on something who we don't know who owns it? But we have this, and this is one of the few laws on seabed minerals in the world. Norway is one of the very few. I think maybe 2 or 3 countries have got such a law. So this is really important. The impact assessment, as I said, started in 2020, will end just in a few months. Then we'll know. So my forum, if you like, my forum, our forum, it will cease to exist if there will be no exploration licensing in 2023, I guess, because then we'll wait another 50 years for someone to another crisis, another war or whatever. But so it's a crucial time, 6 months from now, very important for Norway. Now the political decision, second quarter, and now maybe you wonder, the production for Norwegian waters will then have to happen after such an exploration has happened. I don't know. I even don't dare to say the number. I just put some question marks. If you look at the Norwegian oil and gas licensing, it started with exploration in 62, 63, and we started production in 65. So that took only 2-3 years, more or less. So I don't think it will be that fast because you need to have environmental check. You have to do impact assessment for environment, for even when, if you get exploration licenses and you go into production, you need to have an impact assessment for each of the projects. So it will take time. So I wouldn't guess, but I would be surprised if it happens before 2030. But I just put it as a question mark. And basically, that is what I have to say. So thank you very much for your attention. And I'm happy to answer questions if you have any. Thank you very much.
You are muted, Anastasia. Sorry.
Thank you very much, Egil. That was very interesting talk and eye-opening. I didn't know that. I didn't know about my phone so much. So, and yes, I would like to invite everyone for questions. And yes, that was very, very good learning, I believe, for everyone. Yes, Charlie?
I'm sorry. Thank you so much for that presentation. It was very, should we be typing the questions in, or are you allowing the mics to be on?
Yes, you can ask just out loud like this.
Okay,
And some
great.
people maybe prefer to type, and that's okay as well. And I can announce the question.
Okay, thank you. This was incredible. Thank you so much for this informative presentation. I'm based in New York City. I work in tech. And my question, one of many, is regarding the technologies that are needed. I know that many of them obviously have not been developed yet, and there's a process of different types of technologies that will be rolled out over the next couple of years. What, in your opinion, are the technologies that are most needed right now at this stage to move the process forward? And is there a way to bring the public in at this level in terms of developing technologies and entrepreneurs in this process?
Thank you very much, Charlie. That was a very good question. I would say it's a twofold question. When I talk about Norwegian waters, we're talking about exploration, and that if I would invest my money, I would go for exploration companies trying to locate resources. That's kind of the business for Norwegian waters. When it comes to the international waters, I guess you know that the metals company, they are listed on New York Stock Exchange, and they got quite a lot of money from investors doing polymetallic nodule production. So they are going for production. So they're kind of two. So exploration for Norway now, because we need to get the regulatory framework ready. When it comes to the, if you want to risk your money, I would say that you would need transport systems, processing systems for the nodules coming up to the vessel. That's a big challenge. If you produce, as showed one of the pictures, where you see that there's a production line now, just a test production from 4,500 meters in the Pacifics, between I didn't say where it was, but it's between Hawaii and Mexico, and I mean it's a huge area. We're talking about millions of square kilometers, so it's massive. I mean, as I guess I don't know what your background is, but if you're an investor, just imagine the manganese price of manganese could collapse because there's so much manganese out there. So that's one of the consequences. So there are certain things, but I would go for production. I would go for ways to process materials. I would also go for the shipping, because you need to ship this from far out in the sea and so on. When it comes to the public, that's the more tricky thing, because there are certain strong forces saying that this is polluting the planet, we're destroying biodiversity, we are destroying the planet, and so on. So I think the most important thing is that we have to comply with the ESG goals. If you don't comply with the ESG goals, then you are in big trouble. And that is kind of the reputation of the whole business, not just for production, but also for exploration. So I think ESG, which of course is very kind of important now for all businesses, but not least this, because people, they would rather have cobalt in their iPhones than cobalt from the deep sea mining. How could that be? I mean, if you have seen pictures from, I didn't show you a picture from a mine in Congo, but I mean, it's not a nice site. So it's kind of some people call it dilemma, but it's of course, it's a decision to be taken, but it's kind of a problem. You like to make the earth better, but you still keep on doing all the dirty stuff, and you don't want to risk kind of the biodiversity in the oceans. So therefore, my suggestion is go for kind of a public attitude of doing things in the right way, not as kind of quick and dirty and fix things approach. I hope you got that, Charlie.
Yes, I did. Thank you so much for that. Amazing. Amazing. Thank you.
Thank you, Egil. Anyone else? You can always try.
Hello. Hello. Hello.
Hello, we can hear you.
Can you hear me? Hello. Yes. I am Adumako from Ghana. I'm an economic geologist teaching at one of our mining universities here. And I must say that this is another wonderful and brilliant presentation. I really enjoyed every bit of it. Thank you very much for the invitation. My question is, I don't know if I heard it right or I got it clear. We know that with minerals and with metals, you have different kind of distributions of these metals around the world. Some regions have, particular enhancement of particular minerals. So I want to find out, I didn't hear you say that, maybe it was my network, but I want to find out what particular rare metals have you, encountered in the Norwegian Sea, if there are, and what is the way forward in extracting those metals? Because I know in some other parts, different kinds of rare metals. How about Norway, the Norwegian Sea, please?
Thank you very much. I'm happy to hear you from Ghana, because if I remember right, you had another name, the Gold Coast, right? So Ghana is it's a gold country, right? So yeah, there is a little bit of gold there. So don't worry about that. You will still need the gold from Ghana. Scandium is one of the materials that we have found in excess in the Norwegian waters from the samples. Scandium. I mean, we are talking about also kind of common materials. Copper will be a big demand for the energy transition, because if you're going to wire up things, copper will be always in demand. If you're going to increase kind of EV cars all around the world, 80% EV cars globally by 2040, you need so much copper. And copper is one of the materials that you find in the sulfides in the Norwegian waters. So I would say that you find most of the materials out there. Scandium is to be frank, I don't really know what we use scandium for. I'm sure it's used in our mobile phones, but
yeah,
you you see my point. But if you look at the rich deposits, I think you see most of these elements that you find in around copper. It could be zinc, copper, and materials typically around copper. And gold, of course. Gold and silver is normally byproducts from copper production. I can just give you an anecdotal stuff here. When the Norwegian mines for copper started to deplete 30, 40 years ago, they actually earned money from gold and silver, accessory metals following the copper. But yeah, so but it's great to hear a comment there. It's I didn't mention too much about it, but I said to Charlie here, remember, if you start to produce worldwide in the area, you may start to make some kind of challenge for some of the metals produced, manganese, for instance. And that is one of the worries for United Nations, because they don't want to destroy kind of the money coming from the low-income countries, because many of the low-income countries are dependent on metal production from landmines. And if you start to produce big time in the ocean, it could be a kind of stress for these countries. Therefore, there is a certain rent, an interest, if you like, coming from this to the low-income countries and for the landlocked countries. I hope that answered a little bit of your question.
If I may ask the next question from Charlie.
Yes, please. Yes, please. Thank you very much. Thank you.
Thank you very much, Kofi. Okay, so the next question is with regards to international waters, how does Caribbean play into deep sea mining? And if any of islands participating in this or vulnerable to this process?
Did you say Caribbean?
Caribbean.
Yeah. Well, I can just say that the International Seabed Authority is located in Kingston, Jamaica. So that is in the midst of Caribbean. So yeah, I mean, the decision of all the political processes are happening there now as we are speaking. They're sitting in Jamaica now discussing what should happen for in 6 months. So the big discussion, I mean, this is a good discussion here right now for EAGE. I'm so happy to be here. But the big questions are really happening in Jamaica, in the Caribbean right now. Yeah, and they're discussing these things. When it comes to the resources, I don't know, because Caribbean is a very complex geological area. It has deep water, it has shallow water, it has carbonate reefs, and so on. So it's really challenging. And I'm so I don't know the resource potential, but I'm pretty sure that all the islands in the Caribbean and also the countries around Caribbean would have a possibility for deep sea mining. But I'm not sure of the numbers. I've never seen that. But yeah, so Caribbean is a very important, just politically and also resource-rich area. Yeah.
Charlie, I hope that was your question is answered now. And another question from Charlie: if Norway is open to partnerships and solutions by companies in other waters. And Charlie
Yes.
says, wow. So
It's
I
easy.
guess that was
It's
a good
easy.
answer.
It's easy. Yes, it's okay. Yes. The answer is yes. It's very easy. Sometimes the questions are easy to answer. Yes. Norway have always been working in this kind of process of cooperating with other countries. Oil and gas is an example. And the laws that we had on seabed minerals in 2019 is based on the oil and gas law. And it's the same thing. We invite all companies to join in, because I think the Norwegian government or politicians, I think it's better to join forces than try to do it alone. It's better. Yeah. So the answer is yes.
Thank you very much. Has anyone else got the question?
I feel like I'm hoarding all of the questions. I'm sorry.
Questions.
Thank you. I'm mixing it up. I'm typing some, I'm talking a little. Thank you. Such great. Okay, so this is a twofold question. The first part of the question, which I'm sure you probably presented, I came a little bit late, my apologies, is in regards to the risks. I understand from my limited knowledge that the risks have primarily to do with the environment and the economic, impact to countries that rely on mineral production. Okay, but are there other risks? Because I'm hearing in other ways from other people that there are risks with regards to us not knowing what's really down there and bringing up something that, it's like if you, finding something, I mean, there's all kinds of things. Let's say virus, I'm being ridiculous, but viruses, I'm saying, like, is there other risks other than the ones that are obvious that we've seen in research that you think we should worry about?
It's a good question. If I should answer you in the frankest way, I would say I mean, the risk is a reputational risk. Yeah. I had enough. I mean, the rest is. I mean, we know what's down there. I mean, there are some small. There is a biodiversity down there, but it's not really significant. But of course, you can wreak havoc if you start to destroy kind of chains of there. But I think that I don't know if you are an investor or what you are, but to me it would be environmental reputational risk, which I guess is the toughest one. Yeah. But apart from that, it's just based on Adam Smith and the invisible hand. If the market is there, things work. Capitalism work, as always. If it's nothing there, nobody will. I mean, you will do some tests and lose money. If it's really a gold mine there, in inverted brackets, then it's good. So I don't know, Charlie, if you Yeah, so that's my simple answer to that. But no virus, don't worry about that. No. It's not dangerous to be down at 4,500 meters, even though it's a bit deep and very few people have been down there. But no, don't worry.
Sorry, I had to go sci-fi on you on that one. I apologize. Although that ties into education.
Please do. Please do.
All right, we are already almost an hour, so it would be nice if we soon finish with the questions. So yes, and we've got another question from Charlie. If you follow the SDGs, will that be enough to satisfy environmentalists?
I will just jump to the numbers. Look at 14 then. That is the most important, as life in ocean. Yeah. Look at number 7. It has to do with affordable and clean energy, which is important. Look at number 1, eradicate poverty. Good. Look at number 2, hunger. Look, so the 17 SDGs, yes, probably there will not be enough. Environmentalists will probably say that we don't know enough. But the problem is that when we wait, as we wait, the world is in a big, dire and difficult situation. So the question is, should we just wait to cover all the other 13 SDGs, or should we do something that really saves the planet? That's the big question. And that is not up to me to say. That's up to the politician to say. But if we just sit there and wait, then things are not going the right way, as we all know. So we have to do something. We can sit there and discuss, which is nice now. I like to talk to you guys, but which is good for scientists and good for research. I'm from NTNU, university. So we like to do research. But if you think of the planet, we have to do something. And I hope we do it in the right way. That's the only thing I can say. We should do it in the right way. I don't hope. We should do it in the right way. And I'm sure that there are a lot of clever people here. And you amongst them, I mean, you will find solutions to tackle this. This is my optimistic view. But I don't know what will happen. The politicians, in the end, they will have the saying, or maybe the economists that will invest. So, yeah.
Thank you, Egil. And there is one more question from Charlie. How does this compare to mining in space?
Oh, come on.
No. Which is the better option and less risk?
No. Forget about space. Just forget about it. Okay, Charlie, it's good try, but just forget about it. The message is, it's nice. You can read about that in sci-fi and you can see it. You can watch movies, but just forget about it. It's no business in that. No, it's too far out and too small volumes and too. No, the logistics does not work. But yeah, Elon Musk. Yeah, I met Elon Musk in Stavanger at ONS. So he didn't talk about space mining. He talked about other things, but not space mining. So, but yeah. He may be busy with Twitter. Yes.
All right. I think we need to slowly close. And just before everyone goes, I would like to remind you that the next talk will be in January, 19th of January, and it will be presented by Victor Ore. I hope you see my screen now. And he is a geophysics advisor for Schlumberger Norway Technology Center. And I hope to see you there. It's again at 1 o'clock. It's also an online event. So I hope you will sign and invite all the interested people as well. So if there are no more questions, yes, recording will be provided. I will send you the link. And yes, to all the people who sign up for the webinar. It will be published on EAGE YouTube channel. Okay.
Thank you, Egil.
Last chance for someone to write a question and we go.
But I can comment myself. Thank you very much, and Maria, for inviting me. And I look forward to Victor. He's a good friend of mine. He's a really good presenter. So from SLB, and so I look forward to the January event. And it's great to have you there. I mean, the whole business is depending on experts like you, and I mean that's how it works. And I'm so happy that you have this chapter in Stavanger. I'm really honored, and it's a great pleasure. And I'm happy that the line, even from Brazil, works fine, and it seems like it was better than it's thought. Good.
Thank
so
you very much.
amazing.
Yes. Thank you very much for managing this, even while traveling and being in Brazil and with this connection. Yes, and if somebody would like to give a talk, please send email to you can see the email that Maria Josefina has just posted, or if you didn't find it, just send us a mail back. You probably all received the email from me, at least. Anastasia Jakobsen, Earth Science Analytics. All right, we are then closing the meeting. Thank you very much.
Thank
Have
you
a nice
very
day
much.
in Brazil.
Thank you. Okay. See you then. Bye bye.
Bye bye.
Bye.